Hi, my name is Paul Coward. I'm going to show you how to build an application-based data warehouse. I've been in the computing industry for almost 50 years. I started my career working for the Department of National Defense, building the surface-to-air weapons information system, which is used to determine a ship's readiness for combat. I then went to work for various oil and gas companies. I even started a few of my own companies, which were mildly successful. In the past 8 years, I had been working for ConocoPhillips as a senior data architect in building their information management solution for the Canadian business unit. This is basically what I built for them, and I'm going to show you how to build this. I'll give you detailed information on the design of the warehouse, along with software that'll help you implement such a warehouse if you want. Let's first take a look at what the problem was. Well, like a lot of businesses, we had applications, and the applications were selected by departments, and they satisfied the need of that department. However, when you start to look at data and start to use data in other departments with the cross-department boundaries, you need to transmit that data. For example, we transmitted the data from an application to a GIS engine so that we could better work with it on a graphical basis. We also then sent it to our Spotfire engines and our Power BI engines so that you could graphically represent information. And lately it's been more on tune of analytics, machine learning, and AI type engines. That's one application. So you can see for one application, I'd have to build 3 different interfaces. Now it's compounded when we bring a second application in because I'd have to build 3 separate interfaces. Plus, if there was any joint shared data, I would have to worry about how do I share it. So I would have to either share it at the level of the Spotfire report or at the ArcGIS level or the analytics level to merge that data together. And a third application, you can see that. So I'd have to build for 3 applications 9 different interfaces. Now this became not very practical for a maintenance standpoint. So what we looked at doing was building a data warehouse. So what data warehouse do we build? Well, I designed one that is application based. We clearer later when we talk about and show you this how the application based is different than just a conventional data warehouse. Okay, so first of all, we have application data sources. We have a number of different sources of information. Now, for each source of information, I would build an interface into our application data warehouse. So that meant that I only needed to build 1 interface per application, not 3 in the other design. However, I did have to build initially 3 different interfaces, one for ArcGIS, one for our Spotfire Power BI, and our analytics engine. So that meant that I could add a new one without having to build any new interfaces to our presentation layer. So let's take a look at what it is. We have a multi-tiered, the design of the data warehouse is a multi-tiered data layer. So what does that mean? Well, so we still have our applications, and we'll show our different data layers as we come in. The first data layer, which is to move the data from our data source into our staging area. And this is usually done with the ETL process. I don't like to do any translation at this time. I usually like to just do an extract and load into our stage. So once the data has been staged, it then moves into the second layer, which is the production layer. So we take the data, we move it into the production layer. Some databases require you to copy data, and in this warehouse, in our design, in my design, I'll show you how to do it without copying data. You just rename tables and everything just happens. So the third layer, which is a semantic layer, this is where you actually do the work, where you actually merge data sets, you do other types of things with the data, you either convert it to a particular unit of measure or whatever is needed to that. That's your semantic layer. Now, usually the semantic layer will feed into a common data model, and I don't really recommend putting a common data model in. I've seen lots of people try to implement common data models after the semantic layer, i.e. like the PPDM model or other ones. The problem with that is it takes a lot of resources, and your people are spending more time moving the data from the application into that common data model than taking the data out of and make it available to the end user in the presentation layer. So I actually kind of put that out there. In my documents, I show you it, but I take it out here so that I strongly recommend not using it. My practices have never shown me that there's any value in it. Now with the data in the presentation, that is what gets sent out to your ArcGIS engines or your Power BI Spotfire engines and or your analytics team. So to give you an idea, when I started ConocoPhillips, we had three applications going into our data warehouse. Initially with about 200,000 rows of data and representing about 10 users. Today, they're up over 50 applications, representing over 500 million rows of data and over 1,000 users. Now, the other layer that I also added into this is a service layer. Now, the service layer allowed me to take data from our presentation and push it back into the data sources. Now, the other thing in the service layer, which we'll show you, is things like notifications. When a certain event occurs in our organization, I can notify people that that event has occurred. Example being, when a rig release has occurred, we needed to notify certain people that the rig release had been done. And it made it very easy to do this through the data warehouse. So the other thing I like to talk about this implementation that I'm going to propose here is scalability. So we started with a couple of applications. I said we started with 3, and we growing it organically. That means that we just kept adding, but based upon the need of the business, not just based upon what I felt we needed to do. So the other thing that we had doing is we started to do a job, for example, to do reserve analysis. Now, the reserve base became very, very large and started to impact our data warehouse. I mean, we had 4 terabytes of space bed up there, and they were actually consuming almost 4 terabytes themselves, having an impact on our data warehouse for everybody else. So what we did is we cloned it. So we actually cloned the data warehouse. So we run parallel data warehouses. The other thing that we did do is we actually run one in serial. That means that one data warehouse will feed another. For example, we have data coming from something like SPO, which is our smart plant, which has our documents. It goes into our application data warehouse. The data then is transmitted again, formulated and retransmitted into another application data warehouse, which is visualized and utilized. That took the load off of one machine, and we could use another machine and more and different disk space and stuff like that. So it actually increased the performance. The whole thing is about increasing performance. The last thing we were kind of working on, which was getting the data through to the cloud. Now this really showed where the warehouse really became advantageous. So instead of having 5 different, or in Conoco's case, 50 different interfaces, one for each application into the internet, we basically only needed one interface, which actually enhanced our security capability, because we could only need to pipeline one system through to make this data available. The other thing that we're going to be looking at was putting the application data warehouse up on the cloud itself so that we could feed data. That's very doable because the application data warehouse I'm going to show you is designed and built using or on Oracle. Okay, so this is where the naming standards that we used, and within the data warehouse is why I call it an application-based warehouse. So all objects within the warehouse are prefixed with an application abbreviation. So the first thing you do is you establish an application. Is this an application source, or is this an application a producer data, or is it a consumer data? We give it a code, an abbreviation, and then all the objects that pertain to that particular job or that particular process is given that acronym. So example, ADW is prefixed, is reserved for application data warehouse. So ADW, any object, table, a view, a materialized view, a process, a function, is prefixed with ADW. ADW underscore, and that determines that that is an application data warehouse object. Now this became very important because we had a number of people working within the same warehouse, and they would not conflict with their names because each one of them worked with a particular application. So they didn't have to overly worry about what they were naming things, because they controlled their own names by prefix and everything beginning. So you'd have multiple, for example, project tables or project data sets. I would have, IDW project, or I'd have a LPS project. So I could have multiple project tables, but each one of them are different based upon the application. Now, all the application abbreviations and information is stored in an ADW application table. And I'll explain a little bit about this application table later, which is fairly critical and strategic in helping you document and maintain your application. Now, the other thing we do is the suffix is used to determine what type of object and what layer it belongs in. Okay, so for example, if something was suffixed with _s, it was used for a table within the staging layer, because _p was used for a table within the production layer, and _b was used for tables backed up from the production layer. Now, so what happened is once data was staged, it was put into an _s table. When it was completely staged, the first thing that happened is if there were any _b tables for that particular application, they would be removed. Then the _p would be renamed to _b, and the _s would be renamed to _p. By the fact that you're renaming, meaning that you're actually not deleting the object. The object exists, and so if somebody had grabbed that object, that table, and using the data in that table, they grabbed a particular object number. They never grabbed it by name. That's one of the unique things that Oracle does. And so therefore, they never lost their connection when I brought in and renamed the tables, which actually was a fairly nice thing to have happen. The _v's were used for virtual views. So that means we directly connected some data directly to the application so that we could show data as it is current. The other ones in production were usually a day back, so they were done last night's data. Most people can get away with a day. They don't really care too much. Some people want to have every 10 minutes. We have some, or every 15 minutes. We actually have these, which are some that they want it right now. Well, you know exactly what that invoice is and things like that. And so we also then had another thing called _VW, which is for views. It is recommended that procedures and functions use views of the production table, not the production table directly, because they'll break. _MVs are for materialized views. Again, it's recommended that materialized views only be created from a view. _SAQ is for sequences. _PK is for primary keys. We use a number of different other standards as well. For example, triggers would be BI for before insert. Triggers that were _BU were before update. So first of all, let's talk about building the warehouse, which is the code I'm going to provide you. The code is in GitHub, and there's the address that you need to go to get the data. So you can see it's GitHub Paul Coward 53 ADW. Now what you do is you just basically download and zip it into your C drive under ADW. You have to create an Oracle account, ADW admin, with SysDBA privileges. He has to have elevated privileges. He doesn't need full DBA privileges, just elevated certain privileges like grants. He needs to be able to grant for security purposes, be able to create and drop. So those type of standard protocols. Now, first of all, you copy the commands that are in the AW install SQL to an Oracle worksheet, and then you just execute the command. It'll build your data warehouse for you. That's how simple it is, and I'll give you actual demonstration of how to build this in other videos. So let's take a look and review first, define an application. An application itself can be a producer or consumer of data. Application abbreviations and information is stored in ADW application table. Okay, so now this is what this table looks like. So the first thing is a unique index for an 8-character application ID. and it's used to identify the application. Again, standardly, here's a description of what it is, okay? Now, the field called SOR, which is used for system of record. Is this a system of record? If so, what is it being a system of record for? So you're talking about what this application is. Now, the other thing is very critical components to get information on, and it's easier when it starts than it is later on, which is the data owner. Who owns the data? It's usually a department head. It's not, too high up. It's usually a department head that owns the data. The data steward. Who is the data steward? The data steward is somebody appointed by the data owner to be responsible for the data. So the data owner who has privileges to grant access to the application and is responsible for the data content. Now, they usually oversee some data custodians who edit and control the data. Sometimes the data steward and data custodian are the same. Now, it's important that you document this information as you go along, because when you start to get to 60 to 70 applications, you realize that you now have accumulated a wealth of knowledge of how your environment is set up, and you need that information, because later on when you start to say change applications, you need to be able to go back and find who the data steward was, talk to the data steward, and try to keep this as updated as possible. So process logging. So what we're going to talk about is basically the components that make up our application data warehouse. Process logging is being able to manage a job if it's successful or failed, and to be able to tell you why it failed or what the results are. So all jobs or procedures log messages, normal and errors. So there's basically there are only really two types of errors. The standard tables that are used are ADW process execution and ADW process log. Okay, a job is assigned a particular session number, and one entry for that job is made into ADW process execution. Each job is assigned a session number using the ADW session. Okay, now each line, as a job progresses, it basically will make entries into the ADW process log. So each line is associated with a given session number or a log entry, and then it's also put out in sequence so that you can actually read it, so it looks like a proper thing. The package used is AWS process package. I'll go into more detail on how to use this package and how it works in additional videos. So all entries to process logs should be utilized this package. Everybody should. Python uses it. We'll use it. Built it for Python and also within Oracle itself. So let's talk a little bit about ETL, which is one of the mainstays of any application data warehouse. The first part we're going to do is Oracle. So in other words, an Oracle application feeding into our application data warehouse. How we do this is using DB links, fairly straightforward, and it's a tool that provides by Oracle. Okay. Some people complain that this is a security breach. It is not if the link of the owner of the DB link is the same as the owner of the application data warehouse. So every application will need to have an ADW admin user access to their application. Now, on their application side, what privileges that user has, we only recommend it ever select. We never update it. Later on, in certain cases, we update it, as I said, when we fed back to the surface layers. Then we'd have to have update capability. So we define an ETL from an Oracle server. Okay, so the package, the PL SQL package we use, which is ADW ETL, controls ETL from Oracle to Oracle. ETL uses this table, ADW ETL stage, to define what ETL. So in that table, there's a field called application ID. So we know that we need to have the application ID. The ETL group, this is used so that we can group data sets that span maybe multiple applications. So in other words, trying to synchronize across application boundaries. Very seldom have I ever used that required, and most of my stuff has been through an application boundary, all the data within a particular application. The ETL sequence is just basically a sort sequence for ETL order. I've never really come in a case where I said, oh, this table has to go before this table has to go before this table. Very seldom has that ever happened. I don't think we really use it too much at all. The ETL type, which this controls this type. So Oracle can only be one of three types: DB insert, DB copy, or local. Now, DB insert basically uses a slower process than insert, and it inserts only so many records at a time. This is beneficial for services that are remote and that basically are subjected to failures because of proximity and Oracle downtimes. So they pull pieces of data at a random thing. DB copy basically copies the data. It's one statement copy, very high speed, Oracle to Oracle. Local means that you've had a secondary service feed the data, and then now you want to process that data in the secondary service. There for example, we had Informatica feed data into the warehouse, and we needed to pick up when Informatica had completed and done it. So they were what we call local. The ETL parameter, this was used to tell me what DB link to use. Okay, the ETL source schema was the table owner. So when I went to that, what table do I need to get the thing? And ETL source table is the table, the source table that I need to pull. And it also sets a trigger into the ADW tables, which that's a table that is going to store the data in. Okay, to set it up for Oracle applications, you create a DB link, and the recommended is a prefix with the application ID _link. That's our naming convention I want to use. The other thing you do is create a procedure to execute the ETL called your application ID _build. If you stick with these conventional naming processes we put forward here, things become very easy to locate, understand what they are, and as you grow to having thousands and thousands of jobs running simultaneously, it becomes very easy for you to see what's going on. So here's a sample of an ETL setup, for example, a PDM build that I had here. Now, this you'll see here, this is where it starts to use its logic for process that we talked about. So AW process begin, and they give it a name. So basically, we start this process, we call ATL load for that particular application. Now, if there's any semantic processes we need, we do it here, and then we just do a process end. Now, to trap an error, we just basically do this. That traps in the error that comes out. Very straightforward, very simple to use. Okay, and we add the ETL list to that table, this ATL table that tells me the list of tables that you want to bring over. So now with SQL Server, it's done a little differently. We use a Python job called ADW SQL ETL. But I also included this thing called AW connection PY. Because we have to have a connection where we have to store the password, and we need that password encrypted. So I have provided you with a Python job that will encrypt the passwords, so that if somebody happens to get a hold of your connect file, it's secondary. They have to know your special key, and each of you can build your own special key, and we'll talk about that when we talk about deploying and putting it together. Again, you'll see that this thing here takes from the application server and feeds into the data warehouse through the stage layer. Okay, so we define ETL for that. A Python job controls the SQL Server. ETL uses ADW stage to define the ETL. Again, that's the same way. Applications that in that table, application needs to identify the application. ETL group is in a group of which spans multiple applications. Your sort sequence. Now, your ETL type has two types: MS insert or BCP transfer. So MS insert will actually do an insert into the table, pull the data into memory in Python, and insert it into the database. BCP transfer is a block copy transfer. It is used the BCP command in SQL Server to transfer the data to a disk drive, and then use a SQL loader to take that data and push it into Oracle. Very high speed. You can push a lot of records through pretty fast that way. Most data sets are fairly small, but if you run into a large data set, BCP transfer is the best and ultimate way to go. ETL defines what connection in my AW connections table to use. Okay. ETL source schema, that's the table owner, right? And then your table to pull down. So at the end of every ETL, the security process gets called, and basically it allows the user to what data they can see. It's application centric. In other words, usually you say, okay, this person can see all of this application. The nice thing we wound up doing at Conoco is they said all data is important to everybody, so we don't want to restrict. Now, what we didn't have in our warehouse, which I strongly recommend never put into a warehouse, is HR data, because it is very confidential. But if you have confidential data, you can lock it out so that only certain people can do it. I recommend probably splitting part of that data out into a separate warehouse and controlling who can access it. But it's table driven and uses a package AW security. Fairly straightforward. I also show you how to do this in a subsequent video. Notification process. Again, I will show you in a subsequent video, but this process is used to notify users of errors or application settings. So in other words, if a value's changed, you might notify a user. We also notify that, maybe the ADW administrator that this job failed. And it uses an ADW notification list. Uses the package is controlled using ADW notify. The other thing is a mailing process. So in this one here is going to be unique to each of your implementations, even if you implement it locally on your machine. This is a Python job which sends AW mail. So AW notify would actually make entries into the AW mail send. And then you need to build a process to mail. I provided you with a sample of a Python job that does that, but you're going to have to set up your own authentications and your own certifications for it. You define users by groups and mails, and again, I'll give you how this mailing process works in more detail. Again, it's based on a Python job, and you'll have to modify it based upon your installation. So that basically concludes my introduction into the application data warehouse. As you see, the application based data warehouse is based upon each set of attributes or each set of objects being assigned to an application and given that application prefix. So it actually is encompassing, not only are we giving you code, but we're giving you a process, a way in which to manage the data internally within the data by using a proper and efficient naming convention. I've also provided on the GitHub code that'll allow you, and then we'll talk about other things about installation and certification of your database. It will check the your application data warehouse to see if there's any violation of any rules. And that's important to do that daily. You don't want a rule to be stuck through. For example, you have rogue tables that left up for some reason. You don't want them hanging around. You want to know if things aren't clean in your database. If you have broken jobs because of certain things, you want to know that those jobs are broken, and you are going to have to go through and effectively change it. So what type of errors we wound up seeing in our data warehouse at Conoco was basically pretty interesting, because the only errors we really seen were where somebody had changed a password, and actually we had one case where they introduced they put a new application and didn't bother to tell us. And all of a sudden, when the ETL occurred, we automatically get notified if there's table names or not table names, but field names change, or a table's missing, or something like that. And we started to notice this for application. And when we went back to this data steward, we found out that they were doing an upgrade, and they never bothered to tell us that there was an upgrade coming down. So it took us a day to correct up the upgrades, and everything was fine. The organization's dependence on the application data warehouse became very high. Matter of fact, the amount of time, actually, I think there was only one time I'm aware of it went down at all, which is a credit to Conoco's IT staff, their database people. But one time, one of the DBAs decided to take the database down for whatever reason and didn't bother to notify anybody. And I think it was 15 minutes till the IT manager get a call from my department head saying that that system is down. They need to get in there and corrected it. They come running to my office and said the system is down. I said, yeah, I noticed that, and I'm trying to find out why. And we found out why, and half an hour later it was done. But that was the only time that we've ever had an outage. You kind of plan the outage when you synchronize and set your jobs up to run. My recommendation is, for example, you run all your jobs in the evening, as many as you can in the evening, and your work day is Monday, Sunday night, Monday night, Tuesday night, Wednesday night, Thursday night, Friday night is the weekend. So you prep up for the weekend runs. So we had some weekend and we had some monthly runs. Some fairly large data sets coming through. And some of the data was only updated monthly, so it wasn't really advantageous to do it every night. So in the weekly run, I set a time aside, which I would strongly recommend you look at doing, and coordinating this with your IT staff, your database staff, the people who do your backups and stuff, to coordinate when would be a good time to allocate that your data warehouses would be unavailable. Now, it'll be usually available. We opened up a 4-hour window, and we said from 12 on to 4. On Saturday, we had to give them some time during the day. We didn't want the DBAs working every night. But each organization will have a time. You've got to spend time. You've got to allocate time for down outages. What we call planned outages. And you try to schedule it on the weekend, which is minimally disruptive. Your application data warehouse will be very extensively used day and night. People will be using it throughout the day and into the evening to do various analysis. You don't know when they're going to be doing it. And it's important because data is centric to everybody's job. So this concludes this video. As I said, I will make other videos as become available to help explain things. If you have any questions, please forward me any questions to pcoward53@gmail.com. I will try to answer any of your questions you have about the warehouse. The intent of this is for people who do want to have an application data warehouse, that they don't have to really spend a lot of money. All this stuff is free. And if you're interested in knowing what a data warehouse does and how to build one and how to make it operational, hopefully this will help you guide. So thank you very much.